9.1, we are going to look at polar coordinates. Our main goal is to look at, well, what are our polar coordinates? How do you graph them? How do you relate them back to what we know from trigonometry? And to our rectangular coordinate XY system. So that's what we're going to do in lesson 9.1. Now, the way that a polar coordinate is that we have a polar axis. We have the origin here. We have some angle measure theta that we have traveled, and some r. As you can tell, this very much is related back to our vectors. So that's kind of why we are looking at this. Instead of a point written in an xy component like a vector or a xy coordinate, we are going to use an r theta coordinate. So you'll notice that our first one will describe the length, and the second part of our polar coordinate is going to be our angle measure. So you'll notice that relates very much to what makes a vector a vector. So that's why we need to look at what a polar coordinate is. Now, polar graphs can be really cool. We're not going to have enough time to look at polar graphs, but hopefully that's something you'll be able to explore in the future. Let's just look at how we would graph these. So if you see a polar point, 345, that's telling us that our r is 3 and our theta is 45. And so we know where 45 is. Here's 45. And that means we would go out 3 units. So that's exactly 3 units in length. Okay, so that's 345. And let's take a look at negative 1.5 and 2 pi over 3. So our r is negative, and our theta is 2 pi over 3. Well, just like when we dealt with trigonometry where our x and y might be negative, and we built those triangles that were in different coordinates on or different quadrants on the xy plane. This kind of will happen here. So what I want to first look at is, what is the 2 pi over 3 line? Well, we know 2 pi over 3 is the same as 120 degrees, and it's roughly right here. Now, if we continue going, let's continue that through the origin and going down here. So this is 2 pi over 3. Okay. If we go 1.5 units upward, that would be the point 1.5, 2 pi over 3. But instead, what I want to do is I want to go 1.5 units in the opposite direction. So this negative means opposite. So it technically lands us down there. So even though it says 2 pi over 3, what that negative does is that negative lands us 180 degrees away from there, okay? So that would be, technically, it kind of is the same as 1.5 in the 5 pi over 3 direction. Okay, so those two things are the same, and that really goes back to our trigonometry when we had, things that were coterminal, things that landed us in the same spot. We can kind of think about it as, well, what's in the opposite direction. What's 180 degrees away? And that's what that means. Let's do another one. So we've learned that negative means we're going to go downward. So we're going to go negative 30 degrees there. And we're going to go 3 units out. 1, 2, 3. So here is positive. Here's positive pi over 2. There's positive 1 unit. So negative 1 unit would be down here. So that is how we would draw part D. Now I want to talk about a polar grid. That's what that you see here, okay? Now each one of these, so here you can kind of highlight our traditional kind of X and Y axis is kind of hiding in there. And you can see our unit circle kind of is based in there. But let's say that we, let's graph a few points on the polar grid. So let's say we want to go 5 pi over 6. So we would go to the pi over 6 line and we would count 5 circles out. 1, 2, 3, 4, 5. So there's that one. Let's swap colors here. Let's do 2 pi over 3. We would go to the 2 mark, and 2 pi over 3. Let's do negative 1, 4 pi over 3. So here's the 4 pi over 3 line right here. But now we want to go in the opposite direction, exactly opposite of it, so that point would be right there. So that's a polar grid. Polar equations have r's and thetas in them. You'll see equations like r sine theta, r equals sine theta, or something like that, and they'll give you lots of neat equations. Try it in Desmos, you can find lots of cool stuff that go with polar equations. So let's do a little more practice here. So let's find 4 pi over 3. So that's your r, that's your theta. So we're going to go over to the 4 pi over 3 line. We're going to go 3 radiuses out. Let's do negative 3.5, 150. Remember, that's our r, and that's our theta. So what's 150? Well, you might recall that 150 is 5 pi over 6. So that's this line right here. But we want to go in the negative or opposite direction. So we're going to go 3.5, 1, 2, 3.5, right there is where we're going to land, okay? And let's do this one here. Negative 2 is our r. Here is our theta. Okay, so we have 2 negatives here. So first let's find where is negative 135. So 135 is right, it's the 45. Let's find it. It's right here. But we want to go, instead of the second, not instead of here, we want to go exactly opposite of that, which is here. So that is our answer right there, that little green point we see right there. So they're graphing on the polar grid. Now, let's practice taking our polar coordinate, our theta, and changing it into Cartesian or XY coordinates. So in our first problem here, our r is 4, our theta is pi over 6. Now, if it is a unit circle value, like pi over 6, I need you to use the unit circle. I want an exact value. if it were something like 10 degrees, 46 degrees, 48 degrees, something like that, you would want to use a calculator, okay? But this is one that's on the unit circle. So first, what is our x? Well, our x is going to be r cosine theta, which is 4 times the cosine of pi over 6. Our y is going to be r sine theta, which is 4 times the sine of pi over 6. So our x is going to be 4 times square root of 3 over 2. Our y is going to be 4 times 1/2. So this is going to be 2 radical 3. Let me make that look a little better. And this is going to be 2. And so our xy coordinates that would get us on the same spot is 2 square root of 3, 2. Now let's practice another one. In part B, our r is 3. Our theta is negative 120. If we look at the unit circle, negative 120 lands us here. The point is negative 1/2, negative square root of 3 over 2. So let's keep that in mind, okay? So our x is r cosine theta. Our y is r times the sine of theta. So x is going to be 3 times negative 1/2. Our y is going to be 3 times negative square root of 3 over 2. Let's reduce that as much as we can. X is negative 3/2. Sometimes on this iPad I can't make 3's very good. And our y is negative 3 radical 3 over 2. Let's write that in xy component, just regular xy coordinates. And there we go. There's an example of changing a polar point into an xy point. So that kind of you can see it uses our trig. This is all we needed to know from section 9.1. The homework that we are going to use is, you see right here, these 10 problems. So there you go. Okay. Thanks, guys. Bye.